You know, I am I'm afraid of this kind of type of video that I'll be doing. So today I'll be trying to solve 50 integrals in one sitting, and the integrals that I obtained are from James Stewart calculus book, the ninth edition, metric edition to be precise. So the integrals that I'll be solving is randomly, meaning that it could either be a trig function, algebraic function, partial fractions, integrate by part, etc. And I have around like 50 of them. So, and it's not in order. It means that some of which, um, maybe I'll start with an easy one, maybe I'll start with a hard one. It depends. It's just randomly. So, so let's start. Don't want to waste much time. So, okay, the first one is pretty much direct. So the first one, the lower and upper bound is 1 up until 2. The function will be x plus 1 square divided by x dx. This will be our first integral of the day. And what we are going to do is, by expanding the numerator, we'll expand the numerator to obtain x squared plus 2x plus 1 divided by x dx. And you could like separate this single term to 3 different terms. So, well, 3 separate terms. Anyway, by doing so, you will have x plus 2 plus 1 over x dx. And from this expression, you could just obtain the integral very nicely. So, well, knowing your basic integration rules on formulas, you can solve this very easily anyway. So x squared over 2 plus 2x plus ln of the absolute value of x to 1. You can solve this. So you have 4 divided by 2 will be 2 plus 4 plus ln of 2 minus with 1 over 2 plus 2 plus ln of 1. Ln of 1 just basically means 0. So here you can simplify further like this. 4 minus 1 over 2 will be 7 over 2 plus ln 2. There you go. As a math student, we have to make sure our final answer is exact in a way that ln of 2, I'll just leave it as this. I will not be rounding up like to 2 or 3 decimal places. But yeah, let me check. I do have the answer scheme on me, so I'm relying on technology currently to just determine whether my answer is correct or not. So not 2. Alright, nice. First one down, we have 49 to go. So the second one consists, which is we integrate 2 1 x over x plus 1 square dx. Alright, so this integral is a partial fraction, repeated linear factors, which means that we have to build up the power for our denominator here. So I'll be focusing on the algebraic function first. So I could separate this into 2 different terms. We decompose this term into 2 different terms. And one of the cool things that I've learned recently is that there is this method called the cover-up method, or cover-up rule, whatever you want to call. Just basically, here I would like to, well, if I get this as 0, then I could obtain the value of b, which means that the only x value that makes this term 0 will be -1. I'm not talking about the whole term. The whole term will be undefined, obviously, but the denominator, I'm just focusing it on the denominator. So this video was, well, the technique itself, my friend told me about it, so it's very useful anyway. So just basically, since we know that -1 will create this as 0, you could obtain the coefficient b. The value will be -1, because, well, this satisfies this, but we can't obtain it for this term. For like repeated linear factors, we could only find the coefficient for the last term for the power itself, like b over x plus 1 squared. But for a over x plus 1, the way you want to solve it is just you have to first by creating this expression, this equation, all right? Well, we know that b is -1, so you get like this, and then you copy a by substituting any value. So let's say x is 0. So when x is 0 means that we could solve a very easily. So a is equal to 1, which means that this integral can be expressed as 1, 2, and then 1 over x plus 1 minus 1 over x plus 1 square. Yeah, I believe that's the correct way. So from here you could integrate it as usual, minus plus 1 over x plus 1 to 1. I'm not skipping a few steps, I'm just basically integrating directly. I assume that most of you have the basics. It's just that how are we going to approach a particular integral? So from here, just substitute your boundaries, your limits here. So ln of 3 plus 1 over 3 minus ln of 2 plus 1 over 2, and you could solve this. So it will be ln 3 over 2 and then -1 over 6. So here you go, that's your answer. And I believe that if you aren't used to the cover-up rule or the cover-up method, I recommend you guys just solve it as usual. Like there are methods of solving repeated linear factors, or basically in general partial fractions. Just one, you try and error with any kind of value of x just to satisfy a particular coefficient, or you could just compare the coefficients. You could create a system of linear equations and solve from there as well. It's up to you, but I want to solve this very quickly. So yeah, that's basically much about it. So let me check my answer. By the way, if you are like in a rush when you watch this kind of videos, you could speed it up. No problem from there. So let me check. Yep, the answer. So nice, means that we are on the right track. So far, no issues. Alright, we have an indefinite integral. So we have, my gosh, e sine of x over secant of x dx. Okay, so this indefinite integral, what I want to do is, we know that 1 over secant of x means that cosine of x. So I could just express this as cosine of x times e to the power of sine of x. Now, if you aren't like getting used to using integrate by part, I recommend that, well, I can't recommend it. Basically, the approach that I'll be using is using substitution, and after using the substitution, I'll be using the integrate by part method. So here I'll be letting u as sine of x. And when I take the first derivative, I will have cosine of x dx. So essentially, I will have the integral of u e raised to the power of u du. And now you recognize this. You could solve it by using integral by part. So we will be using w, that's my term, and I'll be replacing w as v and u as v. In other words, it will be wv is equal to, sorry, wrong one, v dw is equal to wv minus w dv. So basically, I'll be using this kind of form to solve this by using integration by part. And yeah, so dw will be the exponential function. Oh, by the way, the only advice that I could give if you want to solve integral by part and determining which one will be your u and which one will be your dv or whatever it is, usually back in like pre-uni level, I recommend my students to use a LIPET, LIPT, I suppose, LIPT, whereas you prioritize the left hand side more than the right hand side. But as you move forward, there are a few questions where you can't use this acronym, and therefore you have to use logic to choose which term will be your dw and dv or du, and dv and u, to proceed with the one of the techniques, which is IPP lah. And yeah, but one of the ways that you want to be familiar with which one you want to set as your dv and which one will be u, you have to solve more questions. I mean, that's the only approach that I could recommend, like what I'm currently doing, 50 integrals. Okay. So let's proceed. So by integrating this, you will have e to the power of u, and here your v, you integrate u in respect of, you integrate v in respect of u, sorry, yeah, you're integrating u, so you will have the u. Okay, my gosh. Yeah, you are integrating in respect of u. That's what I'm trying to say, sorry. So so the next step is just multiplying this, multiply by this, but you have to integrate that bottom part. So you'll be having u times e to the power of u minus e to the power of u du, and solve as usual. And don't forget about your constant c. And we know that the term u will be sine of x. So sine of x, e to the power of sine of x, minus e to the power of sine of x plus c. If you want to make it fancier, you could factorize e to the power of sine of x like this. And there you go. I believe this will be the answer. So give me a brief moment. I want to check because I don't have the answer scheme with me. So I have to use a website just to check for this integral. So e to the power of sine of x divided by secant of x. Alright. E to the power of sine of x. Wait, did I make any mistake? Oh. My apologies. I don't know what happened. Okay. This is, I don't know why I okay, so I did a mistake here. Yeah, if I rearrange this, I don't know why I did an oopsie here, but basically you could substitute, yeah, just substitution. There's nothing about integrate by part. So here you know that sine of x will be u times with du because of this substitution is equal to e to the power of u plus c. You have e to the power of sine of x plus c. I mean, I'm sorry. Alright, sorry. Anyway, well, okay, so question 4 here, we have from 0 up until pi over 6 t sine of 2t dt. So here, obviously, well, you can't use any substitution, doesn't work. So you have to use IBP. So from here, your dv will be sine of 2t. And you integrate this, so you have negative cosine of 2t over 2t, sorry, 2. And your u will be t. You differentiate this, you get du equals to tt. And now, you should get negative t over 2 cosine of 2t pi over 6, 0, minus the integral of negative cosine of 2t over 2 dt, which is 0 up until pi over 6. And I'm gonna leave the left hand side, the left term. I will not be solving it first, but I'm gonna leave it as this. So pi over 6, 0. Here you could, well, simplify this, cosine 2t over 2 dt, and now you could combine both terms in one because you'll be integrating both sides. Plus sine 2t over 4 pi over 6, 0. So now solve as usual. So you will have negative pi over 12 cosine of pi over 3, and then plus with sine pi over 3 over 4. And now when you substitute t is equal to 0, the first term will be 0, then sine of 2t will be 0 as well, so just adding 0. And now what you can do is, I mean, from here you could solve, nothing much to do. Sine, but I don't make mistakes. Cosine pi over 3. Okay, so first will be negative pi over 24. Then the next one will be plus the square root of 3 over 8. So that will be your answer, right? So let me check. X sine 2x. Yeah, I should get the answer. So negative pi over 24 plus square root of 3 over 8. Yep, it's nice. So the next question 5 here. Question 5 will be, so they give us an integral of 1 divided by 2t squared plus 3t plus 1 dt. So first things first, can we like factorize the denominator? So that's what I'm trying to know first. So from here I could see that I can. So 2t squared plus 2t plus t plus 1 dt. We know that the denominator could be factorized as so 2t plus 1 2t plus 1 t plus 1. Very nice. So from here, partial fractions as usual. So 1 divided by 2t plus 1 t plus 1 is equal to a over 2t. A divided by 2t plus 1 plus b over t plus 1. So by using the cover rule, you can obtain your coefficients very easily. So we know that this term, if we want to make it 0, t has to be equal to negative 1 over 2. So which means that a can be negative 1 over 2 plus 1, meaning that we will not using this. We cover that part, we only focus on this part. So the same goes for coefficient b. We know that the value of t, when it's equal to negative 1, the denominator here will be 0. So therefore, we could substitute negative 1 into this part, into that part. Therefore, a will be 2, then b will be, well, negative 1. So basically, you could obtain 2 over 2t plus 1 minus 1 over t plus 1 dt. And here you can obtain your particular integral. You have 2t plus 1 minus ln t plus 1 plus c. And then by using the properties of logarithm, you could combine these two to be in this form. Right? And don't forget about your answer value, okay? So when you solve this particular question, so let me check first, as usual. X to the power of 2 plus 3x plus 1. Yeah, we have the same answer. Honestly, right, if you could like express as what I did here, then please do so. The simplified the answer is, the more simplified it is, the better your chances on like giving a good impression, meaning that you know your properties of logarithm and such. Okay. Alright, 6. Question 6, they gave us, oh, okay, a really interesting integral here. So we have 1, 2, x to the power of 5 ln of x dx. So for this integral, you have to solve using IBP. Again, by determining dv, it will be x to the power of 5, and by integrating it, you will have x to the power 6 over 6. How about your u? Your u will be ln of x, and du will be 1 over x dx. And now you can solve this very nicely. So x to the power 6 over 6 ln of x to 1 minus with the integral of x to the power 5 over 6 dx. And now, oh sorry, forgot my limits here, so 2. And now you could solve this, x to the power 6 over 6 ln of x to 1 minus with, well, essentially I could just combine both of them, no problem. So x plus 6 over 6 ln of x minus x to the power 6 over 36 to 1. Now you can solve this. So 2 to the power 6. Well, I mean, I can factorize, well, I don't care, honestly. 2 to the power 6 will be 64. 64 divided by 6, if I simplify further, it will be 32 over 3 ln 2 minus, well, 64 divided by 36 will be 16 over 9 minus with, well, ln of 1 will be 0, so I'm left with negative 1 over 36. Now I can like simplify it further. So 32 over 3 ln 2, 16 over 9, plus 1 over 36. So that will be, oops, yeah, negative 7 over 4. So hopefully that will be the final answer. So let me check yet again. X power 5 ln of x, so 5.64, 32 over 3 ln 2 minus 7 over 4. Yeah, you have that same answer lah. Okay, so far so good. Question 7 here. Question 7, we have the powers of cosine and sine. So 0 up until pi over 2, sine to the power of 3 theta, cosine square theta d theta. And now, well, there are many situations, many cases, but for this case, first we know that sine to the power of 3 theta could be separated to be sine square theta times with sine theta. So what does this mean? 0 up until pi over 2, it will be sine square theta cosine square theta times with sine theta d theta. This is important is because that we will be using substitution, but before we have to do that, we know this is a definite integral, meaning that the boundaries have to be different when you apply this substitution. So what will I be doing is creating an indefinite integral, and from there I can like solve directly for my definite integral. So let me just create an indefinite integral below here. So sine square theta is just basically by using one of the trig identities. You will have 1 minus cosine square theta. So 1 minus cosine square theta times with cosine square theta and times with sine theta d theta. So the substitution will be, of course, cosine theta will be the substitution. So let u is equal to cosine theta. Taking the first derivative will be negative sine of theta d theta. So here we will have negative 1 minus u squared times with u squared du, and you can solve this directly as usual. Well, I'm going to get rid of the negative, so by expanding it I will have u to the power 4 minus u squared du. And now solve, well, this is elementary, nothing much you have to do. So cosine theta to the power 5 over 5 minus cosine theta to the power 3 over 3 plus c. Very nice. And now, by going back to your definite integral here, all you have to do is just basically write it down back. Sine cube theta cosine squared theta d theta, and you can directly solve it by referring to your indefinite integral here. So now you have this cosine theta to the power 5 over 5 minus cosine theta to the power 3 over 3 pi over 2 0. So solve it directly. We know that cosine of theta, when we substitute theta pi over 2, it will be 0 if I'm not mistaken. So let me double check here. Yeah, it'll be 0. So basically the left hand side will be 0, the minus will be cosine of 0 will be 1. So 1 over 5 minus 1 over 3. Therefore, you will have negative 2 over 15, which means that it will be 2 over 15. So that will be your answer. Let me check again. Cosine of x. Yeah, 2 over 15. Nice. So that's very cool. So let's move forward to question 8. So question 8, they give us 1 over x squared, the square root of 16 minus x squared dx. Okay, so well, directly seeing this, I can just use trig substitution. So I'll be substituting sine of theta, or to be more precise, 4 sine of theta for my x. And hopefully from here I could do something, because I believe that for sine square theta it will be cosine square theta, so I have to remember back my integrals. Therefore I need to do something a bit. Well, obviously I'll be referring to my notes for, yeah, easy. Anyway, but yeah, substitution. So let x is equal to 4 sine theta. Taking the first derivative will be 4 cosine theta d theta. And from here, you will have 1 over, well, 16 sine square theta. And then, well, I'm gonna show it. So 16 minus 16 sine square theta times with 4 cosine theta d theta. So this term, you could express it as 4 times square root of cosine square theta. So 1 over 16 sine square theta. So you have to remember that 16 here could be factorized, and the square root of 16 will be 4, and this 4 can be cancelled out with this 4. Therefore, you are left with the square root of cosine square theta times with cosine of theta d theta. And from here, well, first we have to remember that the square root of a squared term, it will be an absolute value. So here will be the absolute value of cosine of theta. So you have to mention to the reader, as you guys are, we have to restrict the domain for theta. So theta, cosine of theta will be larger than 0 if theta is between negative pi over 2 and pi over 2. So you could get rid of the absolute value and you are left with this 1 over 16, the integral of cosecant squared theta d theta. Now, I will not be showing on how to solve for cosine square theta, but basically the integral of cosine square theta will be negative cotangent theta. So you are left with negative 1 over 16 cotangent theta plus c, and you have to draw a right angle triangle if you want to leave your answer in terms of x. So let me make one real quick here. Okay, so the angle theta, so by using Saussure-Trois, we know that so, meaning that the opposite divided by the hypotenuse, so it will be x and 4. So our adjacent would be 16 minus x squared, the square root. So by referring to this, well, to those who don't remember, on the acronym for cotangent theta, you could just express cotangent theta as cosine theta over sine theta plus c, and you could see that for cosine theta it will be side hypotenuse, and then sine theta will be opposite hypotenuse. So essentially, if I recall, it will be the square root of 16 minus x squared over x plus c. So that will be your answer. Yep. Okay, so let me just check a bit. Where's my oh, here it is. So 1 over x squared square root of 16 minus 16, got m 16 minus x squared. All right. So yeah, that'll be your answer. Wait. Yeah, correct. Okay, so let's move forward to question 9. Question 9 here, we know that given the integral, which is sine ln of t over t dt, so this you could use substitution. So let u is equal to ln of t, the first derivative will be 1 over t dt, and by rearranging this term, you could see that you could substitute very easily. So you are left with sine of u du, and moving forward it will be negative cosine of u plus c, therefore it will be negative cosine of ln t plus c. So I believe that's the answer. Anyway, moving forward to question 10, we have the integral, a definite integral, from 0 until 1 for the square root of arctangent of x divided by 1 plus x squared. So not to worry about this integral. If you recognize the substitution, then there should be no problem by recognizing the first derivative of arctangent. So let u is equal to arctangent, and by finding the first derivative, you will have 1 over 1 plus x squared dx. And as you can see, by rearranging this, well, I'll be creating an indefinite integral first. So let me create one real quick. And when you rearrange the terms, you could see you could substitute very easily, and you can solve the integral from there. So I'm left with the integral of the square root of u du, and you could solve this. We know that the square root of u will be 2 times u to the power of 3 over 2 over 3 plus c, and we know that u is just basically arctangent. So I'm going to write down as arctangent of x to the power of 3 over 2 over 3 plus c. So here's your indefinite integral, but the question wants us to solve the definite integral. Therefore, rewriting it back, 0, 1, the square root of the arctangent of x divided by 1 plus x squared dx, you will obtain the following. Will be 2 over 3 arctangent x to the power of 3 over 2, 1, 0. So arctangent of 1, let me go back. Arctangent of 1 is just basically pi over 4. So 2 over 3 pi over 4 to the power of 3 over 2 minus, well, arctangent of 0 will be 0. So you are left with 2 over 3, well, the square root of pi to the power of 3 over 64. I mean, I believe I can solve this further. The square root of 64 will be 8. Therefore, well, 8, 4, so you're left with pi to the power 3, the square root of pi over 3 over 12. Yeah. So that should be your answer. So let me check. 0 to 1, the square root of arctangent of x divided by 1 plus x squared. Hopefully, there should be no problem. So far we are around like 20% of the whole set. We are left with 40 more, right? So the square root of pi, about 3 over 12. Very nice. So yeah, let us move on to question 11. Question 11 gives us the integral of x times ln of x to the power 2 dx. So, well, this is very nice using IBP. So let u is equal to ln of x squared. So we know that the first derivative will be 2 ln x over x. How about dv? It will be x dx, and you can solve this. So you will have v is equal to x squared over 2. You should obtain, which is x squared over 2 ln x to the power of 2. Yeah, I am correct. Minus with the integral of ln of x dx. So if you don't remember, because we solved this previously, I believe did we solve this previously? Yeah, I believe that is question. Oh, we didn't solve this previously. Oh well, just basically just substituting again. So I'll be using the same variables. So u is equal to ln of x, du is equal to 1 over x dx. So dv will be x, and then v will be x squared over 2. So you could solve the integral. So you have x squared over 2 times ln of x squared minus x squared over 2 ln of x, well, plus the integral of x over 2 dx. So from here, you know that the resulting integral for the third term is very nice. It's very easy and very straightforward. So ln of x squared minus x squared over 2 ln of x, and then plus x squared over 4 plus c. So you could factorize x squared. You will have x squared over 4 2 ln of x squared minus 2 ln of x plus 1 plus c. There you go. That should be a resulting integral. Let me check first. X times ln of x to the power of 2. So you obtain, yeah, x squared over 4. Okay, so let's move on to question 12. So question 12, they gave us, wow, okay, the integral of sine of x cosine of x times with ln of cosine of x dx. Well, it looks a very interesting integral, yeah. So okay, let me try and express sine of x cosine of x as in sine of 2x. So essentially it will be 1 over 2 the integral of sine 2x ln cosine of x dx. Okay. Very nice. So let me use IBP, right? So my dv will be sine of 2x. So it will be, well, negative cosine of 2x over 2. And then my u will be ln of cosine of x. The first derivative will be negative sine of x over cosine of x. Oh, so okay, looks promising. Anyway, solving it, you will have negative cosine of 2x over 2 ln cosine of x, and then minus with sine of x over 2 dx. And I believe that all of you know how to solve for sine of x over 2. So it will be plus cosine of x over 2 plus c. And I believe that I could just leave the answer as this, so I don't need to do anything further. So let me check. Ln cos of x. Right. I believe there will be multiple of answers, so it will be not. Oh, cosine square. Oh, I see. Cosine of, oh, okay. So is it correct? I believe so. Cosine square, cosine square. Wait, did I miss anything? So let me check. 1 over 2 sine 2x. Okay, looks good. Oh, yeah, I did a mistake here. Sorry. I believe that. Okay, let me just rearrange this. I believe I forgot about the double angle on my cosine 2x. So let me write it down. Let me write it downwards. Make it visible for me. So equal to. So this will be negative cosine of 2x ln cosine of x over 2. And then this will be, okay, now I can see it. So here we know that the negative, I'm gonna bring it out 1 over 2. So cosine of 2x, interestingly enough, cosine of 2x, I'll be using 2 cosine of square x minus 1. Yeah, I'll do it like this. Okay, so what we're going to do is, by expanding it, you will have negative cosine of 2x times with ln cosine of x over 2 minus 1 over 2, the integral of 2 cosine of x sine of x minus sine of x over cosine of x dx. Alright, we know that sine of x, cosine of x, just basically tangent of x. So tangent of x. And we know that 2 cosine of x, sine of x is just basically sine of 2x. So from here, well, we could integrate this very nicely. I believe that will be the case. So divided by 2, and then, or minus, no, plus with cosine of 2x over 2, and tangent of x, I believe that when we integrate tangent of x, it will be ln of negative ln of cosine of x. Ow. If I'm not mistaken, that should be the answer. Yeah. Okay. Wow. So that's nice. This question is very interesting enough. But give me a second. I would like to check my answer, whether or not is it acceptable. I'm not sure about the domain, because originally ln of cosine of x, they don't have the absolute value, meaning that the domain, I believe the domain will not be much of a bother, as long as, yeah, I'm just gonna leave the absolute value in. I'm just gonna leave it as this. But I want to check first, because I believe that for trig integrals, most of the questions we differ by a constant, so that will be the case, I suppose. 2 where's my ln cosine of x minus 1 divided by everything divided by 4. Alright, so my answer is negative cosine of 2x that multiply with ln of cosine of x divided by 2 and then plus with cosine of 2x and then minus ln of cosine of x. And I believe I have to put the absolute value here, so divided by, oh no, this has to be divided as 2. Wow, we have different answers. So let me check again. Sine of 2x, yeah, I'm just negative cosine of 2x, and I tried to express cosine 2x as 2 cosine square, so yeah, negative tangent, and then did I do any mistake? No. Cosine of 2x. I believe that I have to put here the absolute value. Oh no, I don't need to. Why is it very different? Wow, the integral part. Well, I'm not sure which part that I did wrong. Sine square. How the heck you got sine square? Oh, okay. Oh, wait. Well, this is 4. I believe, yeah. I think I forgot the 4 here. So, it doesn't change anything. Does it change anything? Yeah, it doesn't. Essentially doesn't change anything, honestly. But damn, I can't find the mistake here. Yeah, I'm gonna do 1. Yeah, I'm gonna do P. P stands for problem. For me, it's a problem. I'm not sure which part that I did the mistake on. Looking here, right? Cosine of 2 power 2x. This is troublesome. I can't even determine which part am I wrong. Wait, let me. Ln of x, tangent. The integral of tangent will be yeah, negative ln cosine of x. Alright, I know, I'm not sure, but I'll leave it here. I'll make a specific video about it. I don't know where, because the website showed me different answer. I don't know whether is it correct or not. Or did I miss anything? I don't think I missed anything here. Okay, but yeah, if I did any mistake, please let me know. I'll look this back again later. How many minutes I've been doing this all day? 49. All right, so question 13. Okay, question 13, we have the integral, definite integral for 1 up until 2, the square root of x squared minus 1 over x dx. Okay, so from here, honestly, the only approach that I could think of is the trig substitution. So yeah, I'm gonna create an indefinite integral first. So the square root of x squared minus 1 over x dx, and by letting x as, I believe this is suitable for secant, so secant of theta, the derivative will be secant theta tangent theta. Alright, secant theta and tangent theta. So here will be the integral of the square root of secant squared theta minus 1 over secant theta times with secant theta tangent theta d theta. So I can simplify here further, and the denominator I could express it as the square root of tangent square theta, which means that just basically the absolute value of tangent theta times with tangent theta. So I have to mention about the restriction of the domain for theta. So tangent theta larger than 0 is on 0 up until theta up to pi over 2, which pi over 2 can't be included for tangent theta itself. Anyway, let's move on. So here will be tangent squared theta d theta. So by using one of the trig identities, we could express this as secant squared theta minus 1 d theta. We know that the integral of secant squared theta will be tangent theta minus theta plus c. We could express tangent theta minus tangent theta by referring to our triangle here. So theta will be let me side hypo. So x squared minus 1 square root. Anyway, tangent theta will be to our opposite side, so the square root of x squared minus 1 over 1 means that only the square root of x squared minus 1, and theta will be the arcsecant of x. So yep. Okay, now going back to our indefinite integral, all we have to do is just evaluate it. So the square root of x squared minus 1 over x dx. So the resulting integral will be the square root of x squared minus 1 minus arcsecant of x to 1. And solve this as usual. So you will have the square root of 3 and arcsecant of x. I believe that arcsecant of x of 2, you have to convert arcsecant to arc cosine of 1 over x. So basically, arcsecant of 2 will be arcsecant of 1 over 2. So essentially, we will have, sorry, not arcsecant, it's arc cosine. Arc cosine 1 over 2, it will be pi over 3. And we already reached our domain previously, so it should be no problem. Minus with 0 and then 0. I believe, yeah, it will be 0. No, arcsecant of 1. Wait. Yeah, 0. So we are left with the square root of 3 minus pi over 3. So that would be the answer. I'm still not happy with question 12 here. I believe I did a mistake when I did the substitution, but I can't see it. I believe tomorrow morning I might see it, so I'll create a separate video on the ones where I can't do it by on my first attempt. I haven't done this yet. So the square root of 3 minus pi over 3. Oops, wrong. Pi. Yeah, very nice. So let's move on to question 14. So question 14, we have, okay, this is a very direct integral. Just basically, they gave us the e to the power 2x over 1 plus e to the power 4x dx. And by using appropriate substitution, which is with letting u as e to the power of 2x, taking the first derivative, you will have 1 over 2 du is equal to e to the power of 2x dx. And by doing so, you will obtain the following: 1 over 2, the integral of 1 over 1 plus u squared, because we know that e to the power of 4x could be separated. You have e to the power of 2x to the power 2, which means that u is equal to e to the power of 2x, 1 plus u squared, and you recognize this integral. So Well, you don't need to be fancy enough to, to use substitution. No need to do that. But you know that the basic integral for this is the arctangent. So arctangent of u over 2 plus c, we know that u is equal to e to the power of 2x over 2 plus c. Right? Very nice indeed. So, but I believe that those who are familiar with the integral, you don't need to do the substitution. But for those who aren't familiar, it's okay, you could just use the substitution and obtain the following. Oh man, so let me try and solve it on this website here. I'm just gonna check my answer. You know, it's a direct one. I believe that I could make mistakes as well. Wait. Okay. Okay, yeah. I forgot to. That's why it's very weird. Let me. Alright, so. Okay. Yep, nice. So let's move on to question 15. So question 15, we have. Wow, okay, we have the integral of e cube root of x, which means that x to the power of 1 over 3. Okay, alright, wow, I never seen this before. I believe appropriate substitution will be enough. Yeah, appropriate substitution. So, I believe from here we could substitute the power here. So let u is equal to x to the power 3. By taking the first derivative, it will be 1 over 3 x to the power of 2 over 3. Yeah. This is a very nice question here. So if I multiply both sides, I believe that I will have 3x to the power of 2 over 3 du is equal to dx. So I will have, well, we know that by taking the power of 2 for this, we will have u squared, which means that we could express this as 3u squared du is equal to dx. So from here, you have 3u squared times e to the power of u du. So this is very nice. And I'll be using the tabulous method. So just because I want to save my time, so this will be d, this will be I, means that d will be differentiable. Differentiate, I is integrate. So the term that will be differentiating will be u squared, obviously. Then the integral part will be e to the power of u. So we begin with the positive sign, negative sign, positive sign. 2u, 2, 0. Here u, power of u, power of u, power of u. By multiplying this way, you'll obtain the following. So with 3, u squared times eu, e to the power of u, minus 2u times e to the power of u, plus with 2 times e to the power of u, plus c. And we know that u is equal to x to the power of 1 over 3. So basically we will have 3 x to the power of 2 over 3. Well, I'm gonna factorize e to the power of u. So 3e. So we know that u is equal to x to the power of 1 over 3. So x to the power of 1 over 3. X to the power of 2 over 3 minus 2x to the power of 1 over 3 plus 1 plus c. There you go. Very nice. So we check e to the power of x to the power of 1 over 3. Alright. Very nice. So we got the same answer. Alright. So question 16. 16 they gave us, alright, this is very cool. So x to the power 2 plus 2 over x plus 2 dx. By using long division, we know that this is an improper fraction, so you have to make it proper. Therefore, by using long division, it will be x x squared plus 2x, you will have negative 2x plus 2, and this you could simplify it further, so you have negative 2x minus 4, so 6. So you are left with the integral of x minus 2, x minus 2 plus 6 over x plus 2 dx. So by evaluating this integral, you have x squared over 2 minus 2x plus 6 ln of x plus 2 plus c. So I believe that will be the final answer. And now plus 2 divided by x plus 2. So that will be that the answer. Yes, it is x squared. Yeah, that's correct. Nice. So let's move on to question 17. So question 17, we have the integral of x squared arctangent of x. So for this, you have to use IBP. You can't use anything else. So the dv will be x squared dx. By integrating it, you will have 2x. Sorry, it's not differentiating. X cubed over 3. How about u? U will be arctangent. And by taking the first derivative, it will be du is equal to 1 over 1 plus x squared dx. So you could express this as x cubed times arctangent of x over 3 minus the integral of, wait, let me bring out the constant here. So 1 over 3, the integral of x power 3 over 1 plus x squared dx. Now we know that this term is improper. You have to apply the long division. So here will be 1 plus x squared x plus x power 3 minus, you are left with negative x, and I believe that's about it lah. So x power 3 times with arctangent of x over 3, then minus 1 over 3. You integrate x minus x over 1 plus x squared. Give me a second. Well, I'm gonna drink some water. It's already what, 1 hour. It's 1 hour already. How are you guys doing so far? Hopefully 1 hour into the video, and I am tired. It should not be a problem, right? So give me a second to breathe. Honestly, 17 questions under 1 hour is just crazy for me. All right, so let's move on. Let's continue on. So x over 1 plus x squared. So this integral you can solve by using substitution. So let me first solve one by one. X power 3 arctangent of x over 3 minus x power 2 over 3 plus the integral of x over 1 plus x squared dx. So I'm gonna do it separately. So in other words, by integrating x over 1 plus x squared dx, alright, I'm gonna do it down here. Let u is equal to 1 plus x squared. By differentiating this, you will have du is equal to 2x dx. We know that this could be expressed as 1 over 2 du is equal to x dx. So this means that you're integrating 1 over 2 times the integral of 1 over u du, which implies that you have 1 over 2 ln of u plus c, which implies that's 1 over 2 ln the absolute value of 1 plus x squared. So okay, so here's your your resulting integral. So it'll be x to the power 3 arctangent of x over 3 minus x to the power of 3, is it? Oh yeah, oh no, sorry, to the power of 2. Wait, I forgot the 6 plus, yeah, x to the power of 2 over 6, and then plus with 1 over 2 ln 1 plus x squared plus c. Alright, there you go. Very nice. So that's why I told I believe I told someone about this, that Lipet, is it Lipet? Am I using Lipet? Yeah, yeah, but it doesn't matter as long as you know which part you have to integrate. Should be no problem. Oh, that was tiring. Oh yeah, I forgot to times with 3, so this will be over 6 because we have this constant 1 over 3, so that part will be 1 over 6, yeah. Right, so let's go to question 18. So, okay, 18 here, we have x plus 2 to the power of 2 times x plus 1 to the power of 20. So the way we want to solve this is, since this has the highest power, we want to make sure this is in the single term. We don't need to expand the binomial term. So by letting u is equal to x plus 1, this implies that the first derivative will be dx, and we can express x as u minus 1. So this, we could express every x term with u. So the first one will be u plus 1 to the power of 2 times with u to the power of 20 du. So by expanding the first term, it will be u squared plus 2u plus 1 u to the power of 20. And now by expanding everything, you have u to the power of 40 plus 2u to the power of 21 plus u to the power of 20 du. And by integrating as usual, so you have u to the power of 41 over 41 plus u to the power of 42 over 21 plus u to the power of 21 over 21 plus c. And now we know that u is just basically x plus 1, so we putting the terms in terms of x, so that will be your answer. Very nice. So whenever you see this kind of questions which things crazy like that, we have to expand, just figure it out the best approach, then you could solve it from there. Right, so what will we have? Is it the same? I believe it's the same. Why is it so different? Oh, the expander. Or is it x plus 1? Your inputs. I believe that they didn't use any substitutionism. Oh, oh man, yeah, I did a mistake here. So I explained it wrongly. So sorry. So this should be 22, 20, and then 21. So here will be 23 over 23. Let me remove everything. 22 over 11. And then 21 over 20. Wow. Alright. So apologies. My mistake here. So x plus 1 to the power of 23 over 23 plus x plus 1 to the power of 22 over 11, then plus x plus 1 to the power of 21 over 20. Alright. Oops. 21, not 20. Alright. So I believe it should be no problem, I suppose. I believe that just about it. Okay. So let's move on to question 19. So question 19 here we have the integral of x minus 1 over x squared plus 2x dx. So now we know that the denominator could be factorized, the term of x could factorize as x times x plus 2. And we know partial fractions, decomposition, we're using Colbert rule. So that's the approach I'll be using. So x minus 1 divided by x times x plus 2. So here will be a over x plus b over x plus 2. So to find the coefficient of a, oh god, yellow stuff as in Colbert rule, we know that x cannot be 0. So 0 minus 1 over 0 plus 2 implies that negative 1 over 2. How about b? X cannot be negative 2. So negative 2 minus 1 over negative 2. So this will be 3 over 2. Therefore, this integral, we could solve it as negative 1 over 2x plus 3 over 2 times x plus 2. So just integrate as usual, negative 1 over 2, ln that's absolute value, plus 3 over 2, ln of x plus 1, x plus 1, x plus 2, plus c. Alright, I could factorize 1 over 2, and I can proceed with, by using the properties of logarithm, I will have ln x plus 2 to the power 3 over x. Nice. So there you go. Wow. Right, so let me check my answer here. Alright. I believe sometimes the website doesn't simplify the answer, just yeah, they leave it they leave it as this in particular. Alright, so let's move on. We are now like 40% done. 40%. Very nice. So we have question 20 here, the integral of secant to the power 6 theta over tangent square theta. Right, so we know that the relationship between the derivative of tangent theta will be secant square theta, and I can see that my numerator here, secant to the power 6 theta, I could separate them. So if I separate them, it will be secant to the power 4 theta times secant to the power 2 theta over tangent square theta, d theta. So what does this mean is that we know that secant to the power 4 theta could be expressed as this form, which is, oops, my integral, 1 plus tangent square theta to the power 2 divided by tangent square theta times with secant square theta d theta. By using a proper substitution, we could substitute in terms of u. So this will be 1 plus u squared to the power 2 over u squared du. And we could solve this by expanding the numerator. It will be 1 plus 2u squared plus u to the power 4 over u squared du. And I believe you could separate them. So it will be 1 over u squared plus 2 plus u to the power 2 du. And therefore, your resulting integral should be negative 1 over u plus 2u plus u to the power 3 over 3 plus c. You know that u is from tangent theta, so it will be negative 1 over tangent theta plus 2 tangent theta plus tangent theta to the power 3 over 3 plus c. There you go. So that's very nice. And I believe that should be the answer. If you want to express 1 over tangent theta as cotangent theta, be my guess. I don't see it as a problem. So tangent square. Yeah, same thing. So very nice. So let's move on to question 21. Question 21 will be cosine. Oh gosh. Cosh. Or the hyperbolic cosine. So, well, honestly, the only approach I could think of is IBP. So, dv will be cosh of x dx, and by integrating this, it will be sine of x, and our u will be x, and then the derivative will be dx. So that is wonderful. Now we can solve this very nicely. So x times sine of x minus the integral of sine of x dx. We could solve this, and there you go. Very nice. Very direct integral. Using IBP. So let me check it out. Whether or not do I obtain the same answer? Yes, I do. Therefore, let's move on to question 22. Question 22. Alright, so they gave us a algebraic function, which is x squared plus 8x minus 3 over x to the power 3 plus 3x squared. So since this is a proper integral, I believe that you can separate the denominator. So here will be x squared plus 8x minus 3 over x to the power 2 times x plus 3 dx, and partial fractions, obviously. So it's a repeating linear factor, and the other linear factor here, so x power 2, x plus 3. So this will be a over x, building on the powers, b over x squared, and plus c over x plus 3. So by using the cover up method, the only thing I could use for the cover up rule or method is this both terms. So if I want to find the term b, I know that x cannot be 0, so just substitute 0 for all the terms beside x squared. So this will be -1, and c, x cannot be -3, so -3 squared plus 8 -3 minus 3 over -3 squared. So this will have, well, let me use my calculator. It's late, guys, come on. So just give me some slack. It'll be -2. So now we are left with a, which is a problem. Well, it's not a problem, honestly. Just basically, you have to express this as x squared plus 8x minus 3 is equal to ax plus b times x plus 3 plus cx squared. And we know that b is equal to -1, so I'm just going to do this. And we know that c is equal to -2. So by letting x as 1, you can obtain the following, which is -6 a minus 4 minus 2. Therefore a is 0. Okay, a is 0. Fair enough. So basically, this will be -1 over x squared minus 2 over x plus 3. Alright. Therefore we will have 1 over x minus 2 ln of x plus 3 plus c. So that will be your answer. I believe that the numerator we could I know we could factorize it. Sorry. So x squared plus 8x minus 3 divided by x to the power 3 plus with 3x to the power of 2. Alright. Alright. 1 over... Wait, did I make a mistake here? -2. I believe I did a mistake for a, because -4. Oh wait, what? Okay, it should be this. Oh, okay, so 12. My apologies. So this should be, I'm gonna add 12 over x. And wait, 12 over x? 1 or 9. 9 minus 3 will be 6. -4, -6. A is equal to 12. Wait, what? A is equal to 12. X plus 3, -2x squared. Let's take x as 1. -4, -2. Did I do any mistake here? Hold up. Okay, -10. Wait, give me a second. I don't know where I did a mistake here. 1 plus 8. 1 plus 8 minus 3. 6. Then -1. 1 plus 3. -2. -6. Why on earth am I not getting the answer? This is not good. I don't know why. Did I forgot something? X squared. Decomposition, -2, okay, 3. Wait. Honestly, right, did I miss something? Am I... X plus 3x squared. I believe I didn't miss anything, honestly. Looking here, when I see the scheme, my 8, why is my 8 12? Oh my gosh. Negative. But let me recalculate something first. Oh, is it? Sorry. sorry. -3 square plus 8, -3. Yeah, yeah, -2, literally. Why is it? How did I obtain 3? Alright. Based on this website, it told me that this is 3, so well, if I combine it again, -x plus 3 minus, well, 2x squared plus 3x, so it will be, yeah, it should be 12, right? So if this is 12x, then this will be -3, -2x squared. Alright, I'm not happy with what I'm doing right now. I don't know why. I can't see. I can't. And I tried to regroup them. Okay. This is not funny anymore. I'm tired right now. What happened? I don't know what I did wrong, honestly. I don't want to redo it again because I'm tired. But Huh? Alright, give me a second. I believe that you guys can skip ahead. But I had to use another website. Partial fraction. Yeah. Calculator. You know I love Google sometimes. That you could do this without any consequences. Just by looking it up like, oh, so this is right or wrong. Anyway. Let me retype again. I wanna see at which part of my work. Because I don't want to make a separate video because I believe it's a mistake in my part. Or behalf of me. So let me check it out. Where's the decomposition? Oh, it's okay. Yeah, what? I got 3. Alright, just give me a. Okay, step 1. Alright, step 2. Step 3. Alright, just. Okay. Okay, why you need to solve by using matrices? Hold up. Alright. Okay. Alright. I believe this part here, I did a mistake. So let me just solve it real quick. Okay, so x squared plus x minus 3 is equal to, oh, it's ax times x plus 3. Ah, okay. Wow, alright, I forgot about that, sorry. So yeah, okay, so let x is equal to 1. Therefore, your left answer will be 6. Let me substitute c and b real quick. Negative and then negative 2. So he'll be 4a. Oh, finally. That took me a while. Wow, okay, so a is equal to 3. Alright, very nice. So what does this mean? Is that this is 3. Yeah. My apologies. It's my fault for not noticing it very earlier. But yeah, now you will have this answer. Alright, let's move on now. It took me too long for that question. It should not be that long. 23. So question 23 we have, okay, this is a nice question. So the integral of 1 over the square root of x squared minus 4x dx. Okay, right? So the way we want to solve this is that, alright, first we could bring this out. The absolute value of x, the square root of x minus 4. What am I doing? X squared. X squared minus 4x. X squared minus 4x. Come on. X squared minus 4x. Hold up. Square root. This is what happens when you do too much math and then you're confused. I believe I can solve this. What's the substitution? Alright, I believe the appropriate substitution will be this, or the whole denominator. So I'm gonna try it first. So let u is equal to the square root of x squared minus 4x. So when you take the first derivative, it will be 2x. Well, I can simplify it. So x minus 2 over the square root of x squared minus 4x. Okay, so looks good. I could substitute everything. So 1 over x minus 2 du is equal to 1 over the square root of x squared minus 4x dx. Now you obtain the following. So 1 over x minus 2 du. We know that x can be expressed when we square both sides. This one in particular. We know that for this, right, it's just x, because we know that x is already larger than 0, so we don't need to put the absolute value in. Therefore, this would be u squared is equal to x squared minus 4x. Oh my gosh, I believe I'm making it more complicated for some reason. I'm not sure why. X minus 2. Alright. If I make it more fancier, x squared minus 4x minus u squared equal to 0, completing the square. So x squared minus 2, power 2 minus 4 minus u squared. Alright. Okay. X squared is equal to u squared plus 4 square root plus 2. Wow. Okay. Wait, why am I making it so complicated? 1 over square root of x squared minus 4x. Still thinking about my decision here. X minus 4. You know what? Honestly, right? I don't need to create all of this. I think this is a nonsense of a substitution. I believe what I did earlier was the correct approach, which is square root. I factor it out. Minus 4 dx. Let u is equal to the square root of x minus 4. Du is equal to 1 over square root of x minus 4. Alright, I could see that this would be a suitable substitution, but I have to mention, the absolute value. So dx. So what we can do here is that this, by squaring both sides, we have u squared plus 4 is equal to x. So yeah, we will have 1 over, well, don't forget about the 2. We'll lay outside, so 1 over that as well of u du. So we know that u is equal to it's not u, Allah, it's x. I haven't substituted it. So u squared plus 4. Well, we know u squared plus 4 will always be positive. So what does that mean is that we could ignore the absolute values, so just get rid of it. And we know that u squared plus 4 is basically arctangent at this point. So I believe that it will be the integral will be arctangent of you know what, I can't remember the formula. Wow, okay. Alright, so let u is equal to tangent 2 tangent theta. We know that u 1 over 4 second square theta. We know that this, the derivative will be 2 second square theta. Yup. And yep, we are left with this theta plus c, which means that arctangent u over 2 plus c. So we know that u is equal to square root of x minus 4. So arctangent of square root of x minus 4 plus c. This is not necessarily that is not. Wow, okay, this is a nice question, honestly. All the questions are nice. Most of them are, some of which, the way you want to approach it, I believe that those are very good in integration in my life. It's just trivial. What do you mean by everything is nice? Well, the title says I'm a student still. Why does it say ln? Did I do any mistake here with u square? I got arctangent. Why is it ln all of a sudden? Okay. 1 over 2u is equal to 1 over square root of x minus 1 over 2 square root of x minus 4. Oh my gosh, just realized. Okay, wait, why did I, my god, I forgot. Yeah, it's my mistake. When I check back, I have to bring out the x here. So alright, yeah. Alright, so basically, sorry, I had to pause for a while. So my approach was wrong because I don't know what I was thinking. I was thinking of factoring x squared. I did not know why. Well, that was funny. But okay, so I think 1 over the square root of x times the square root of x minus 4. Now that is a right way to do so. So what do I mean by it? Okay, so basically, the square root of x minus 4, I can let u as the square root of x minus 4 and taking the first derivative 1 over 2 square root of x minus 4 dx, and by multiplying both sides with 2, du is equal to 1 over the square root of x minus 4 dx. So basically we will have 2 the integral of 1 over square root of x du. We know that the square root of x could be expressed as 1 over square root of u square plus 4. Okay. And then what I'm going to do is that I believe that you recognize this particular integral, but I'm going to try to approach it by using trig substitution. So let u is equal to, I believe the appropriate one is tangent. So 2 tangent theta, the first derivative will be 2 secant squared theta. And now what we are going to do is that by doing so, I'm going to skip a few steps, but basically you will have 1 over 2, the absolute value of secant theta times with 2 times secant squared theta. Now by simplifying further, you will have, I had to mention about secant theta, I had to get rid of the bottom part here. So secant theta will always be larger than 0 in the interval of negative pi over 2, not inclusive, to pi over 2. So what does this mean is that we could get rid of the absolute value and left with secant theta. And we know that the integral of secant theta will be 2 ln of secant theta plus tangent theta plus c. And to make our answer in terms of x, the only way that I could think of is by creating a right angle triangle. We know that the theta will be toward the side u over 2 u squared plus 4 square root. So let's try 2 ln secant theta. We know that cosine theta will be side hypo, so it means that this will be the square root of u squared plus 4 over 2, and tangent theta will be, well, u over 2, then plus c. And then from here, 2 ln u squared is x minus 4, so basically the square root of x minus 4 to the power of 2, we don't need the absolute value since we know that that value will always be positive no matter what. So we are left with x, because x minus 4 plus 4 will be 0, so you are left with x. Then, wait, hold up. x minus 4. Okay, okay, it's correct, it's correct. So over 2, that we have u is equal to square root of x minus 4. It's very nice indeed, y'all. So yeah, that's your answer, ladies and gentlemen. Let's move on to question 24. I'm still recording, right? 1 hour and 40 minutes. Okay. 24, we have okay, this is a nice one. So we have the integral of 2 to the power of square root of x over square root of x. So this, all you have to do, substitution, derivative, multiply both sides with 2. So this is equal to the integral of 2 to the power of u du. So by using the rules of integration, you will have 2 times with 2 to the power of u ln 2 plus c. We know that, well, 2 to the power of u is 2 to the power of x, and we can combine them by using index law. We have 2 to the power of x plus 1 over ln 2 plus c. So I believe that will be the appropriate answer. Honestly, I should have done this in the morning, but here I am. Here I am instead, doing it in the middle of the night. And honestly, I'm not a night owl. I'm a guy who wakes up very early, but I decided to ignore everything and just do it. Okay, halfway there. Question 25. Holy crap. Question 25, and I am halfway there. Okay, 25. We have the integral of x plus 1 divided by 9x squared plus 6x plus 5. What did I just said? Plus 5. Okay. So we know that the denominator we could, like, factor down. I believe we could factor down 45. 45. What are the factors of 45? 3. Yeah, 3. Then we have 5. We have 9. We have 15. Wait, can you factor it? Hold up. Give me a second. If not, then completing the square. That's all I can think about. And the substitution. Yeah, I can't factor them. Damn it. But it's not. Yeah, completing the square. So completing the square. So let's see what happens here. I believe that 9. Yeah, to factor 9 first. Yeah. So by factoring out 9, okay, I'm gonna do it separately. The completed the square, CTS. So 9x squared plus 9 times something is equal to 6. So 3 over 2. It's not 3 over 2. It's 2 over 3. So 2x over 3 plus 5 over 9. So completed the square. X. I'm doing very slowly because I'm still thinking of. Yeah. 1 over 3 square plus, no, minus 4 over 9 plus 5 over 9. Negative 4 over 9 plus 5 over 9 will be 1 over 9. So 1 over 9. Alright. Nice. So, now what? Okay, I believe that 9x squared x plus 1. Is that it? Oh, that's literally it. I can't decompose. Is it factored? 18th, no, I can't use the substitution. Direct substitution, I can't. Wait, 18x plus, yeah, I can't. I'm sighing because this is damn tiring. Right. So I believe that we could express it as this form. So 9 times x plus 1 over 3 square minus 1 dx. When I think about it, okay, let me try and... Alright, sorry, give me a second. So basically, I could substitute x plus 1 over 3 with, I think the most appropriate one is second. Yeah, second will be the most appropriate one. So x plus 1 over 3 is equal to, I believe it will be, well, second theta over 3. And then the first derivative will be second theta tangent theta over 3 d theta. Alright, so this is very nice so far. So now what we are left with, we want to get rid of the x terms, so I'll be multiplying both sides with 3 for this, and then I will have second theta minus 1. No. I don't need to multiply 3, just by taking away 1 over 3 both sides. Second theta over 3 minus 1 over 3. So what does this mean? Is that I have this second theta over 3, and then 1 minus 1 over 3 will be plus 2 over 3 divided by second theta minus 1. Second square theta minus 1 will be tangent square, then times with second theta tangent theta over 3 d theta. Alright, so this could simplify further, and I believe that 1 over 3, all the constants I'm gonna bring it outside, so 1 over 9, we are left with second theta plus 2 1 over, we are left with 1 over sine. Yeah, I'm just simplifying it. I'm just simplifying everything, honestly. So 1 over 9, we integrate. Second theta is basically 1 over cosine theta. So I believe, is there any good integrals? Maybe wondering if how many formulas you have to like memorize. Honestly, just too much. You have to really figure out which one is suitable. So basically I'm cheating a bit. I have this formula sheet for trig functions especially. Don't blame me, fam. Yeah. Wait. This is cotangent. What am I doing? It's not 1 over sine theta. Yeah, it is. Cotangent, cosine, yeah, 1 over sine theta. So 1 over sine. So I am left with 1 over sine theta, second theta. Okay. So I am left with 1 over sine theta, cosine theta, plus with, well, 2 cosecant theta d theta. 2 cosecant theta, I think I have no issues. I believe that I don't have any issues. So cosecant theta is just ln. And then 1 over sine theta. Alright, that's going to be a pain. So cosecant, is there any formula sheets? Please do let me know. Cosecant theta. Cosecant. But there's a possibility that I might be wrong. That's about it. that's about it. That I'm currently struggling. Um, 1 over sine theta cosecant theta. I do not know what is the most suitable substitution I could think of. Let me see. Secant theta over tangent theta. Okay, I think I figured it out. Yeah. I think I figured it out. The only way that we could solve this is that, well, I believe that is the only way, is that I'm gonna bring it 1 over 9 first. So 1 over 9. I'm gonna do this properly, even though I'll be sleeping at 1 a.m. just to solve this 50 integrals in one sitting. So this will be secant square theta over tangent theta plus with 2 secant theta. Alright. I believe this is a yeah, this is nice, this is better, honestly. So 1 over 9 ln tangent theta plus 2 ln secant theta plus tangent theta. Alright, oh my gosh. that was a lot of work, honestly. Okay, alright, so this is nice. We have some progress. So okay, what we're going to do is, by referring to the right angle triangle, okay, this is ugly. So cha is side, and then hypotenuse, and then the other one will be, well, 9x squared plus 6x square root. Yeah. Okay. Tangent theta will be square root of 9x squared plus 6x. And then I'm gonna do it down here just because 3x plus 1 plus square root of 9x squared plus 6x plus c. Alright. Yes, cool. Very nice. Okay, but is it correct? That's the appropriate question we want to ask. Is it correct? I mean, the idea is there, honestly. Plus 6x. I can't even write 6x. 6x plus 5. Alright. These belong. Why is there arctangent? Why is there arctangent? Why is there arctangent? There's no way it's arctangent form. Why is there arctangent? That's why is the website telling me there's an arctangent? Alright, you know what? I'm gonna compare. Alright, so basically the website gives me y is equal to ln 9x squared. Because I am using a very different approach, honestly. Because I can't think of another one. I can't, like, using partial fractions, I can't do that. It's just an unfortunate thing that I have to inform myself. I can't just do that. Plus 6. Alright. Divide by 12. Alright, I got the first one. Oh wait, oops, forgot. 9. Okay. So let me compare with my answer. So my answer is 1 over 9. Ln the square root of 9x squared plus 6x plus 2 3x plus 1 plus square root of 9x squared plus 6x. Oh my god, we have different answers. Wow, okay. Looks like we literally have different answers. Yeah, I expect we will have different answers, honestly. I want to see how they approach this problem. Oh, they use substitution. Wow. Very smart. Very nice. Yeah, I believe. Wow, that's a very nice approach, honestly. Honestly, to me, that's a very nice approach that they've done. And I think I know where I did my mistake. Again, this is tough. When you constantly making mistakes, there's a plus here. Yes. I believe those are watching like, fine, you forgot the plus form. Now, I feel stupid. You know, this is not fun. Erasing everything. Oh gosh. But the substitution that they did on this website, my gosh, it's a very genius approach that they could recognize this substitution. What they did was they just multiplied by a form of 1 and then they solve from there. So not gonna lie, that's a very good approach. Anyway, so this x plus 1 over 3 could be substitute with tangent theta over 3. So when we take the first derivative, it will be second squared theta over 3 d theta. So what does this mean? So I'm going to bring everything outside. Now I'm just going to show you first. So this will be tangent theta over 3 plus 4 over 3, because 1 over 3 plus 1 is 4 over 3. So here I'm going to skip a few steps. So second square theta times this 1 over 3 second square theta d theta, meaning that, well, simplify it. And 1 over 9 with tangent theta plus 4. Alright, very nice, it looks promising. So 1 over 9 second square theta plus 4 theta over 9 plus c. And now, you can do whatever you want. No, I'm joking. You have to create a triangle. Theta, so toward opposite over side. So this will be 9x squared. 9x squared. God. Let me just. Yeah. Wait, I have to check first. 9x squared plus 6x plus 2. Yeah. 3. What? Wait, why am I like confused right now? I don't know. Yeah. The square root of 9x squared plus 6x plus 2. So now, just set hypo. So meaning that this will be 9x squared plus 6x plus 2, and then 4 over 9 arctangent of 3x plus 1 plus c. Is it correct? I'm not sure. At this point, I'm taking anything. That's not for me. Wait. Did I miss anything? 3. Oh my gosh, 3x squared, 6x 1, and then ln. Why is there ln all of a sudden? Oh my gosh, honestly. X plus 1. Tangent theta. Minus 409. Wait. One over 9, 1. 1 plus 1. So I'm not getting the same one. Yes. I'm not getting the same one. Oh my gosh. I am having doubts, honestly. Currently, alright, I'm gonna do it again. Honestly, this question 25, wow. You are taking my time, a lot of time, honestly. Okay. Let me do it again. How many hours has it been? It's been 2 hours. Oh gosh. It's been 2 hours. Okay. Alright. I have to be strong. Right, so okay. My first approach was I want to use completing the square. Okay, so 9x squared plus 6x plus 5 is equal to, okay, let me factor 9 out. So 9x squared 2 over 3, 2x over 3, okay, plus 5 over 9. Okay, so by using well, the method that I mentioned, completing the square, okay, so it will be 1 over 3 square, oh, minus 1 over 3 square plus 5 over 9. Okay, now I know where I did my mistake. Very nice, fun, very nice. X plus 1 over 3 square, and then negative 1 over 9 plus 5 over 9 is 4, fam. So 4 over 9. So, yep, that's my mistake, honestly. And I blame myself for not recognizing it sooner. But basically this weekend before, yeah. So, what we're going to do now is doing the following. X plus 1 divided by 9, x plus 1 over 3 square plus 4 dx. And now, by using the appropriate substitution, I believe that x plus 1 over 3 will be best with tangent. Yeah, it's tangent. So tangent 2 tangent theta over 3. So when I take the first derivative, it will be 2 secant squared theta over 3 d theta. Okay, we have something here. So Honestly, I have no hopes, honestly, at this point, whether or not this is the best approach. But okay, I'm gonna be optimistic. So 2 tangent theta over 3, and then 1 minus 1 over 3 will be 1 2 over 3, and then divided by with 4 second square theta times with 2 over 3 second square theta d theta. Second, get rid of it, get rid of everything. So 2 over 3, if I factor that out, then I could have 1 over 9. So 1 over 9, we integrate tangent theta plus 1 d theta. Okay, it looks promising. So 1 over 9 ln, I believe ln, or negative 1 over 9 ln cosine theta plus 1 over 9 theta plus c. Alright, so this is more systematic. Very nice. Cosine theta. So if I go back here, alright, I have to create my triangle now. So by creating my triangle, theta, so to our opposite over side, so this would be, sorry, 2. So 9x squared plus 6x plus 5 square root. Right, so negative 1 over 9 ln chart a side hypo. So basically we have 2 over square root of 9x squared plus 6x plus 5 plus with 1 over 9, so the theta will be arctangent, which is 3x plus 1 over 2 plus c. And since there's a negative 1 here, we could bring it inside the ln using the properties. Therefore, we will take the following: ln the square root of 9x squared plus 6x plus 5. I believe you don't need to put the modulus because of it's always positive, plus arctangent 3x plus 1 over 2 plus c. Ooh, that was nice. That was not fun. That was not fun at all, honestly. That was tiring. Very tiring. Anyway, yeah, it should be the same. So let's move on to question 26. Honestly, it's been 2 hours. Been doing not a lot. Alright, simple integral here. So tangent power 5 theta times with secant power 3 theta d theta. So our goal here essentially is, we know that okay, we know we could separate this as tangent power 4 theta secant square theta. This will be secant theta tangent theta d theta. So we know that if we do the substitution, which is u is equal to secant theta, when we take the first derivative, it will be secant theta tangent theta d theta. So what does this imply? It implies that this could be expressed as 1 minus secant square theta square times secant square theta times with secant theta times with tangent theta d theta. So we know that secant square theta comes from u. Secant theta comes from u. We could evaluate the following, and by expanding it, 1 minus 2u square plus u power 4 times with u squared du, expanding again. You have u squared minus 2u to the power 4 plus u to the power 6 du, and by using the power rule, u to the power 3 over 3 minus u to the power 2 times u to the power 5 over 5 plus u to the power 7 over 7 plus c, and then we know that u comes from secant theta, so secant theta over 3 minus 2 secant theta to the power 5 over 5 plus secant theta over 7 over 7. Right, that should be the answer. Let's check it out. Tangent x to the power of 5 times the second x to the power of 3. Right. How did they got, or they combine? I believe they combined everything. For some reason they want to combine, but but yeah, yeah, so it should be correct. So let me move on to question 27 now. So 27 we have, oh, the next one. So 0 up to 2, the square root of x squared minus 2x plus 2 dx. And I believe I can't just simply integrate this as usual. So 0 up to 2, completing the square, it will be x minus 1 square and then plus 1. If I expand it again, I should get, that's the answer. So from here, I believe that we have to use u sub, goddamn u sub again. So first I have, sorry, not u sub, trig substitution. So I'm going to create an indefinite integral. So the square root of x plus 1 squared plus 1 dx. Now let x plus 1 will be tangent theta, and the first derivative will be secant square theta d theta. So this implies that the square root, that's the square root of, well, secant square theta. And I believe, alright, so I recognize this integral honestly using IBP. So let me just mention about the condition that it needs to fulfill in order to get rid of the square root. Therefore, you will have this. Now solve this. You have to use IBP, and the one that you have to set your dv as is secant square theta. You just separate them, and you obtain tangent theta, and your u will be secant theta, and your derivative will be secant. Oops. Secant theta tangent theta d theta. Okay. So you can express this as tangent theta secant theta, and then minus with the integral of secant theta tangent square theta d theta. Right. Yeah, and I believe that this particular integral, when you expand the second term, when you expand the second term, you will have secant cube theta minus with secant theta d theta. So the cool thing is that we know this is the same thing as the previous one. So this one is the same as this. So by rearranging them, you're just basically getting this particular integral second theta will be ln, yeah, ln. So 1/2 tangent theta secant theta plus ln secant theta, oops, secant theta plus tangent theta plus c. So okay, so now we have to like create in such way. Wait, can I solve this? Honestly, I'm tempting to solve it. Know that. Point 5 and 3. Yeah. Can't solve it directly, unfortunately. Yeah, I have to yeah, indefinite. So 1/2. Okay, so I'm gonna build a triangle yet again, and here theta will be opposite over side. X squared plus 2x plus 2 square root. So tangent theta comes from x plus 1, and then secant theta will be x squared plus 2x plus 2 plus ln the square root of x squared plus 2x plus 2 plus x plus 1 plus c. So to evaluate the integral, we have the square root. Wait. Why do I feel like I did something wrong? Oh, this is minus. Oh gosh. Okay, minus. Sorry. So this should be minus. Wait. If it's minus, then it makes my life a bit easier, you know? Yeah, it makes it easier a bit. A bit lah. Alright. So wow, okay. I do need oh shoot, sorry. I do need to okay. I can make my life easier a bit without doing this. So I know that when x is equal to 0, then my theta, well basically tangent theta will equal to -1, which implies that theta is -pi/4. And when x is 2, tangent theta is equal to 1, theta is equal to pi/4. So basically, right, you will have -pi/4 until pi/4, which is equivalent to 1/2 tangent theta secant theta plus ln secant theta plus tangent theta pi/4 -pi/4. Right. So I'm gonna calculate everything honestly. So 1/2 tangent pi/4 1 over cosine pi/4 plus ln 1 over cosine pi/4 plus tangent pi/4. So what will be the answer? Oh gosh damn, I forgot. I had to make it in terms of ln, so I have to calculate one by one. That's the bummer. Okay. So let me do one by one. So 1/2, then pi/4. Essentially, we will have tangent theta will be 1. The secant theta will be 1 over square root of 2, and then plus with ln square. Oh, sorry. 1 over square root of 2 plus 1, and then minus with -pi/4. I believe cosine is an even function, means that it will be the same, but tangent is not, so this will be -1 over square root of 2 plus ln 1 over square root of 2 minus 1. Okay. So we know that both of them can be combined, so it would be this, and it will be like this. So this is the conjugate of this, therefore you will have 1 over 4 minus 1 will be 3 over 4. Wow. That's really a tough interview, honestly, to me lah. I believe that please be right as well. Yellow. I am so wrong. For some reason, I got a very different answer. Let me just check something first. Oh, it's negative 1 over 2. So this will be 1 over 2, yeah. Oh gosh. Alright. So 1 over square root 2. I have a feeling, right, that I did something wrong. Oh, some else minus. Oh gosh, forgot. Plus 1 over 2 ln. Okay, I'm gonna do it one by one, damn it. I can't just simply write down and thinking that I'm correct. Alright, so this essentially factoring 1 over 2 ln, and I could use the properties. Essentially I have 1 over square root 2 plus 1 divided by 1 over square root 2 minus 1. So 1 over square root 2, 1 over 2 ln 1 over square root 2 plus 1 divided by times the value of 1 over square root 2 minus 1. Why am I getting such ridiculous answers at this point? Hold up, let me count again. Square of x squared minus 2x plus 2. Oops. Oh gosh, not plus 1, it's 2. Yeah, I'm not getting what I need from negative power 4, negative 1 over 2. Yep. Yep. Okay, yeah, I have to write down the official answer first. So it'll be 2.29558 something. So I did a mistake here. I can't afford more mistakes than it is from. This is not me. So wow, this implies that this is 2 over square root of 2, so I could just get rid of this. It means that I could no, I can't. So this here, so 1 over 2 minus 1 over 2 is essentially, oh wait, 1 over 2 minus 1, so negative 1 over 2 square root of 2. Okay, and I'm gonna leave it as this. I'm gonna leave it as this answer here. Yeah, I don't want to simplify it further. I'm just gonna leave it as it is. Right. So will it be the same? Will it be the same answer? Who knows? I am hoping that I don't need to write down again. Okay, I'm getting a lot of different answers here, left and right. Yalla, it's a square root 2. Wait, it's the same thing, right? Well, it should be the same thing, No, it sucks when you can't do much. Negative 1/2. I need to recheck my answer. It's not satisfying in a way that I think I did a mistake around. Okay, so this is. Wait, let me. Wait, what's my previous answer? It's the same thing. So. Wow, okay. I think I did a mistake somewhere. Okay, let me check a bit. So, second cube. Right. If it's wrong means that I'm wrong from the get-go. What? Oh yeah, I'm correct for second cube theta. So, okay, square root of x squared minus 2x. Yeah, I got the same answer. X minus 1 square. Yeah, oh my gosh, I literally got the same answer. I literally got the same answer. But why is my boundaries all wrong? Why is my final answer incorrect? Alright, I'm gonna set SP. Because I got the same form of my integral, but when I evaluate it, I believe I did a mistake somewhere. Yeah, I have to check again. But I don't want to waste my time much, so I'm going for 28. So 28 we have, alright, cosine of square root of t dt. So okay, substitution IBP. So let u is equal to the square root of t, means that du is equal to 1/2 square root of t dt, which means that I have to multiply both sides. We know that square root of t is equal to u, so 2u du is equal to dt, which means that 2 integral of u cosine of u du. So dv is equal to cosine of u dt, sorry, du, which implies that v is equal to sine of u, w is equal to u, dw is equal to du. There, you can solve this very nicely. U sine of u minus the integral of sine of u du. So 2u sine of u plus cosine of u plus c. Then we could just plug in everything back in. Plus cosine. Alright. I'm trying to solve it faster than I can. So some questions take me a lot of time, honestly. It's annoying. That's the annoying part. Oh, I forgot. Two. But anyway, let's move on to question 29. So 29 we have 1/x square root of x squared plus 1 dx. I believe we could use substitution. Yeah, I think, well, I think we don't need to do this, but I'm gonna show it just for fun here. So now we have 1/second theta. We know that, sorry, it's tangent. So second square. Right, sorry. So it'll be tangent theta square root of tangent theta square plus 1 will be second square theta, which means that the square root of second square theta will be the absolute value of second theta. um second square theta d theta. So yeah, from here you could solve it. Okay, condition wise, yes, we have to mention about this, and then we left with second theta over tangent theta d theta. I can solve it further knowingly this is cosecant theta d theta, and then we know that the integral of cosecant theta, I believe, is cotangent square. I believe that's the case. No. Sorry, it's ln. So basically, ln secant theta minus cotangent theta. I know how to derive because I am wasting a lot of time currently. So by building the triangle, theta, top up to the side, x squared plus 1 square root. Cosecant means 1 over sine theta, so of the hypo, which means that cosecant theta will be 1 over sine theta of the hypo. So the square root of x squared plus 1 over x minus just side hypo solves the hypo. Okay, let me write just side hypo, so side y so opposite of y. So 1 over x plus c, yeah. So it's your resulting integral. Alright. It's already been what, 2 hours and 31 minutes. Oh, okay. Yeah, that should be the answer. So let me check for a while, then we can move on to question 30. X times square root of x squared plus 1. Okay. Ln there. Alright. Hold up. Opposite over side, x squared plus 1 square root. So when cotangent means that cosine over sine. So chart a side over hypotenuse. So opposite over hypotenuse. So I'm left with 1 over x. And then sine theta is just 1 over, cosecant theta is 1 over sine theta. Subs of hypo, just flip it around. Arc singe. Oh, okay. Before I move on, I want to check my answer. Y is equal to, where's my ln? Square x squared over x minus 1. The other one will be y is equal to ln the absolute value of x squared. As you can see, I am exhausted at this point. Oh man, but I believe that this is a very nice attempt. I'm literally doing it in the middle of the night, so props for trying. So ln the square root of x squared plus 1 plus 1. Ya Allah. Why do we have always the same, the different answer, huh? Tangent theta. Okay. Let me recheck one by one. So tangent theta square plus 1 will be secant square theta, and yeah, set my boundaries. So since I'm very tired. Cosecant, I believe that cosecant, right? Cosecant. Oh, let's hope, let's hope. Why is it square root of x plus 1? Oh, did I do any mistakes, honestly, at this point? Cosecant, ln cosecant, theta minus cotangent. I mean, I'm correct. Okay. I'm not happy with my final answer. Oh, they did. Oh, they they did that kind of substitution. I mean, fair enough. I believe. Fair enough. They did that kind of substitution, which is nice. Why did tangent theta? Alright, give me a second. I want to check my answer to this book. I'm checking on the website, and the website is giving a different approach. So, chapter 7. 7.7 review. 7 review. Yep, I had the same answer with the, and okay, the same answer to the book. For some reason the website has a different answer for me, but anyway. Question 30. Finally, we have a not really a complicated integral, but by using tableless method, d I, we have e to the power of x cosine of x. Yeah, I'm going to integrate cosine. I don't want to integrate. Yeah, I want to differentiate cosine. So we give positive sign, negative sign. So negative sign of x, e to the power of x. Then we are left with negative cosine of x, e to the power of x. So this is similar. So we start from there, and then multiply. So e to the power of x cosine of x plus e to the power of x sine of x minus integral e to the power of x cosine of x. So basically, we got e to the power of x cosine of x dx is equal to 1 over 2 e to the power of x cosine of x plus e to the power of x sine of x. If you want to factorize e to the power of x, then suit yourself. I really don't mind. Either way, this will be a simple one. 31. As I progressively try to answer more, I am progressively depressed. I'm really tired at this point. Alright, so the next one is that they give us a really nice integral, which is the integral of x times sine of the square root of 1 plus x squared divided by the square root of 1 plus x squared. Alright, this is nice. Use substitution and that should be enough. So, is it enough? Hold up. Square root. Why is there X? Why is there X in front? Oh wait. Oh yes. Substitution, easy. U is equal to square root of 1 plus x squared. Take the first derivative, it will be x over square root of 1 plus x squared. Okay, something not that complicated, honestly. So sine of u du, then negative cosine of u plus c, negative cosine of square root of 1 plus x squared plus c. There you go. Right, so I believe I should get the same answer, right? If I don't, then I'm a riot, honestly. I'm joking. Yeah, this video is very long. It's the longest one I've ever made in one sitting. That's the crazy part of what I'm doing right now. So 1 plus x. I should be more prepared, honestly. I should just like get every answer that I could find and just solve it. Honestly, this is the one of the worst ideas I didn't prepare early on. So question 32. Aha. Okay, so question 32 basically gives us 1 over x power 1 over 2 plus x power 1 over 4. Alright, I believe if I am correct with approach, if I let x as a t to the power 4, then I could make x 1 over 2 as t to the power 2 and then x power 4 as in t lah. And then when I take the first derivative, dx is equal to 4t for 3 dt. And then, alright, so 4t to the power 3 over t squared plus t. So as an improper integral, I have to use long division. No. I could just simplify it further first, then I could, long division. So t squared plus 1. Why did I write down as t squared? So t squared divided by t plus 1 t squared plus t, so negative t, and then plus 1. No, I'm joking. It's negative 1, and then negative t, negative 1 1. So basically we will have 4 integrate t minus 1 plus 1 over t plus 1 dt. So integrate as usual, 2t squared minus 4t plus 4 ln of t plus 1. So we know that t is equal to just substitute x with 1 over 2 minus 4x to the power 1 over 4 plus 4 ln x to the power 1 over 4 plus 1. Alright, very nice integral. Because I did a similar, it's not similar, just basically the idea is that I have to find the smallest power and then try to find the perfect substitution. So 1 over 2 x to the power of 1 over 4. Right. Alright, got the answer. So let's go to question 33 now. Okay. Wow. Question 33 doesn't hold back at all. Okay. How many pages have I been doing? 11. Correct. Cool. Question 33. We have the integral of 3x to the power of 3 minus x squared plus 6x minus 4 divided by x squared plus 1 x squared plus 2. Alright. So this is a proper integral. Let me drink some water. And we can't factor out the denominator. So the question is, what is the best approach? Because we can't do anything about it. But we have to use partial fractions, and then we have to use a trig sub to obtain that inverse arctangent. Well, I mean, I'll try. Okay. I am sighing right now because this is going to be a very tough one. The best approach. Okay. We have the integral. Okay, I'm going to do a partial fraction first. So 3x to 3 minus x squared plus 6x minus 4 divided by. I'm concerned of these final questions, man. Looking at these final questions, it looks difficult, honestly. Yeah, I can try it though. Yeah. Anyway, x squared plus 1 times with x squared plus 2. So what we are going to do is that from here, ax plus b over x squared plus 1, and then cx plus d over x squared plus 2. Alright. So now the question is, what will be the best approach? Now for me, I'll be multiplying everything. I'll be taking the longer route, which is this one, and then divided by everything with x squared plus 1, x squared plus 2. Now we have to compare the coefficients. Now that will be my approach for this question in particular. So plus 6x minus 4 is equal to x to the power 3 plus 2ex plus bx to the power 2 plus 2b, and then plus 6x to the power 3 plus 6x plus d x to the power 2 plus d. And now by comparing the coefficients, a plus c is 3, and then b plus d is equal to negative 1. Two a plus c is equal to 6, and then 2p plus d is equal to negative 4. Okay, so we can solve for c. Yeah, we can solve for c. So a is equal to 3 minus c. So here will be 6 minus 2c plus c is equal to 6, which means that c is equal to 0. Alright, so if c is 0, then a is 3. Very cool, very nice. So a is 3. Now for d, we could solve is b is equal to negative d minus 1. So negative d minus 2 plus d is equal to negative 4, which implies that negative d is equal to negative 2, d is equal to 2, which means that b is equal to negative 3. Alright. So what does this mean? Is that the integral will be 3x minus 3. 3x minus 3x squared plus 1. And then plus 2 over x squared plus 2. Quite. Seems reasonable. Okay, now I have to do separately. I'm gonna do one by one. So I'll be focusing on the first one. I'm gonna factor it. I can't factor it out. But I'm gonna focus on the first one, x minus 1 over x squared plus 1. So I can't do anything about that integral. But what I can do is by substitution. And the appropriate substitution will be tangent. So I know that when x is equal to tangent theta, dx is equal to secant squared theta d theta. So what does it mean? It means that 3 tangent theta minus 1 over, okay, I'm going to substitute directly. So I can solve this. We have 3 tangent theta. 3d integrate tangent theta minus 1 d theta. So tangent theta will be negative ln cosine theta, and then minus 3 theta plus c. So in other words, when I create my triangle theta, so to our opposite side, so x squared plus 1 square root. So this means that negative 3 ln chart a side hypo. Well, if I bring out the negative inside, then I'll have the following: square root of x squared plus 1 minus 3 arc tangent of x plus c. So now the hard part is gone already. We have now left with 2 over x squared plus 2. So if you want to integrate that, then we have to use the substitution, which is x is equal to square root of 2 arc tangent theta. So I'm gonna skip a few steps, honestly. Where's arc tangent? It's tangent theta, and I believe that we are left with square root of 2, and then arc tangent theta over square root of 2. Alright. Okay, so yeah, then we know that x, what's the theta? X. This means that we have evaluated the integral as 3 ln square root. I'm going to get rid of the absolute value because it doesn't matter. Minus 3 arc tangent of x. Okay. Plus square root of 2 arc tangent of x over square root of 2. Let's see. Oh my gosh, this hurts so much. It hurts so much, honestly. This is question 33. So, what? Oh, it's odd number, so I could find the answer. So it will be question 33. Did I get the answer? Yes! Cool. Finally, man. I was afraid that I would get the wrong one, but yeah, we got the answer. Very nice. So, holy crap, that's long. That's a long answer. Alright, 34. 34, we have, alright, sine x, cosine of x. So you have x sine of x, cosine of x. How many hours have I been doing here? Oh my gosh, 3 hours, 50 minutes. And then here I could express as 1 over 2. We integrate x sine of 2x. By using Tableau's method, we will obtain the following. I don't want to dv whatever lah, dv 1 0 sine 2x negative cosine of 2x over 2 negative sine 2x over 4. So boom boom. So we will obtain 1 over 2 negative x cosine of 2x over 2 plus sine 2x over 4 plus c. So in the end, at the end we will obtain 1 over 8 negative 2x cosine of 2x plus sine 2x plus c. Alright, it's a nice integral. So x sine x plus x. But I believe we have the same answer, sorry. Different answer. Oh, we do have the same answer. Come on, website, finally. So let's move on to question 35. Question 35, they gave us a really nice one. A simple one as well, so yeah, it is a definite integral. So we have from 0 until pi over 2 cosine of the power 3x times sine 2x dx. So I could express this as in the following. And by using appropriate substitution, which is du is equal to cosine of x, du is equal to sine of x, then my boundaries will be when x is pi over 2, u will be 0, when x is 0, u is 1. So -2, 1, 0, and then u to the power 4 du, so this implies -2, u to the power 5 over 5, 0, 1. You can solve, so -2, 0, minus 1 over 5, 2 over 5. Oh. Yep. Same answer. Okay. So question 36, we have what? We have. Oh. Okay. They really are challenging, you know. So we have the cube root of x plus 1 over cube of x minus 1. Oh man. I thought I could like solve this under 4 hours, but it's about to be 3 hours in. 3 hours. I'm creating question 36. Okay, cube root. Oh gosh, damn. What could I think of as a cube root? Okay, the only thing I could think of is okay. I have an idea. So let u is equal to the cube root of x minus 1, which implies that the derivative will be, let me think, 1 over 3 x12 negative 2 over 3. So, well, obviously I can't do anything about it, so I'm gonna leave it as this. Okay, this is a good approach. So we have u plus 2 over 3 u plus 1 square. Alright, u plus 1 square minus 1. Yeah, sorry. U. Alright. Well, what do we have here? A repeating linear factor. Now you're gonna solve it. So u plus 2 over u plus 1 square du. So partial fractions. We have a over u plus b over u plus 1 plus c over u plus 1 square. Convert method. Either a can be 0 plus 2 over 0 plus 1 square 2. C could be -1 plus 2 over -1, -1. Then B, could solve it very easily. 0 plus 2 is equal to A. Okay, my A is 2, so 2u plus 1 square plus B uu plus 1 plus C u. I know C is -1, so I'm just going to -u. So let u is equal to, I think the best one is 1. So 3 is equal to 4, 4, 8 plus 2b minus, oh, minus u, minus 1. So 7, negative 4, b is negative 2. So what does this mean? You could solve this. Very nice. So we will have 1 over 3, the integral of 1 over 3, 2 over u, 2 over u, minus 2 over u plus 1, minus 1 over u plus 1 square. So next one will be just solving this particular integral. So 2 ln of u minus 2 ln of u plus 1, and then plus 1 over u plus 1 plus c. We know that u comes from the cube of x plus 1, so the cube root of x plus 1 minus 2 ln cube root of x plus 1 over cube root of x plus 1 plus c. So that essentially is our answer. Alright. So x to the power of 1 over 3 plus 1, x to the power of 1 over 3 plus 1. Alright. Why did we obtain a different answer? Cube root of. Alright, 2 ln, negative 2 ln, negative 2 ln. Why am I seeing such different answers at this point? Okay. Wait, I think okay, let me check back. So I take the first derivative. 1 over 3 minus 1. Negative 2 over 3. So multiply both sides. I know that when I square both sides, it will be u plus 1 square u times u plus 2. U plus 2 square root in cube root. So essentially I will have that. I mean, when I see here, right, it should be no problem. My a is okay. My a would be 2, and my c would be, yeah, negative 1. So when I try to solve further, letting my life on the line. Okay, 1 plus 1, 2, 2 to the power 2, 4, 4 times 2, 8. Then 2b minus 1, 4, negative 2. So essentially I will have this lah. Then 2 ln. Alright. Wait. Oh. It's not. Yeah, it's a cube root x. But it doesn't make any difference. It doesn't make any difference still. It hurts, bro. This is what happens when you don't have answers. I mean, I'm literally depending on 1 over 3 negative 2. find any problem here. I want to see how this computer does it. Yeah, I did the same substitution. I did obtain the same thing. And then, huh? Oh, what have I done? It's not the denominator, it's on the numerator, god damn it. So basically, right, I'm just basically wrong on this point. I have 14 questions left. 14. Yep, I didn't receive it. So basically this will be u plus 2, and then it will be times with 3. So yeah. So it will be u plus 1 square over u. Okay, now that's the correct one. So now, well, obviously I'm gonna expand everything. We'll bring the 3 outside, so 3. Then u square, no, I'm gonna expand. U plus 2. U square plus 2u plus 1 over u du. So what we have here is we begin with u to the power 3 plus 2u square plus u cubed plus 4u plus 2, then divided by u. Now what we're going to do is that we can solve this further. So you have 2u squared, and then plus 2, and then plus 5 plus 2 over u du. Now we could solve this elegantly. So u cubed over 3, no, it's just u cubed. No, 2u cubed over 3 plus 2u, hold up, I forgot my u. U square plus 5u plus 2 ln u. So at the end of the day, you will have to undo to keep root of x minus 1 to 3 plus 3 cube of x minus 1 square plus 5 cube root of x. This is 15. This is 6. Okay. So, yep. Wait, what? Oh, it's a constant, so yeah. Do we? Yeah, I've got the same one. Oh no. Wait. U cubed plus 2u square plus u, or 2u square. Oh, I see. 4u, alright, so yeah. No. What am I doing? U square plus u plus. Is it? Yeah, no. Okay. I'm gonna change my variables next time. U is just confusing. I see it as 4 for some reason. Oh wait, this is 4. for you. It's been 3 hours. Don't blame me of getting tired. Okay, I am currently tired as you speak. I have no water. I am dehydrated currently. So, anyway, 1 plus 4 will be 5. Then we can move on with 3 u to the power 3 plus 2u squared plus 5u plus 2 ln of u plus c. Alright, so what it will be u? So expanding this further, plus 6 but yeah, don't do it like me. I'm just sitting here for like what freaking long time now. I've been sitting here since what? Since 10 p.m. I haven't stood up yet. No, that's concerning. No, that's very concerning. And yeah, that's the answer. So question 37. Okay, question 37 is a bit alright. It's not that alright. The idea is that they give us an answer value. I might as well pause. I'm gonna pause for a while and then I'll go better. Alright, so it's been 3 hours. And I'll be stopping for now. I'll continue on tomorrow, hopefully. I thought I could finish it by today, but there are a few I made mistakes along the way, and I'm not really too happy about it. But yeah, 36 questions under 3 hours. Not too bad, honestly. I could have done better if I do it in the morning. But yeah, 36 questions, and I'll continue on with the remaining 14 tomorrow, and I'll continue on discussing about the questions for the P, which I put it as a problem for myself because I can't get it for some reason. Anyway, thanks so much. Yeah, see you next time. Bye.